Okay, we're live from the 2015 Robotics Leadership Summit at GE's Global Research Center in Niskayuna, New York. We're here with Roland Menassa, GE's Advanced Manufacturing Technology Center leader, an expert in robotics and automating industrial processes. Thanks, Roland, for joining us.
Thank you for having me.
So the first question is, what is advanced manufacturing and how does robotics fit into it?
So, advanced manufacturing is very broad, right? It involves process development, the creation of new processes or techniques in which you do these processes. So it's quite a broad subject, but within manufacturing, certainly robotics has played a key and important role in the last 55 years in really advancing how we do things in the manufacturing process. Robotics certainly has played a key role in material handling of parts within a manufacturing system. It has also played a critical role in process applications like joining, for example, that you see quite rapidly in the automotive industry. And so we think robotics has it's really integrative play within our manufacturing systems. And they continue to evolve in the last 55 years, certainly. But they're really an important part of how we make parts, how we get things out to the customers.
So you say that they've evolved, obviously, since the first one was put on a line in 1961. What is the exciting thing about robotics today? How has it evolved?
Well, if you look at the traditional robotics space, the form factor kind of remains the same, but what has changed is a lot of the computations behind the scene, a lot of the sensors that we've added on the robots. You have now many robotics companies offer integrated vision systems so that we can identify parts without the traditional fixturing methods that we use. So that's a great play in reducing the infrastructure cost to deploy these systems. Other advances we have seen, frankly, it's in the safety. So a lot of companies will use the safe controllers, safe robots, dual check safety, where we can guarantee the speed of the robot, we can guarantee the state of the robot. What that meant, frankly, is again taking out infrastructure that we did not see in the system. So robotics has really advanced in the last 5 years to help us reduce the cost of the infrastructure required to enable these robots in the process.
Is this what they talk about, collaborative? You say safe, or is it?
Yeah, no, collaborative robot actually, it's what we call the new age robotics. That started in the last 5 years. Fundamentally, most robots today are position-based robots, which means they guarantee the position, they repeat that. But when you talk about collaborative robotics, they're actually at the core of their DNA, and they're force-based, which means I can sense the forces of the environment at every joint in my robot arm and mitigate those forces so that now I can work side by side with people. So if I hit something, I can sense that and I can deal with that force. So collaborative robotics space is something really new. And it's a new paradigm. It has really enabled the application, many applications that before we could not even think about. Certainly, there's differences between collaborative and traditional robotics, right? The new collaborative robotics, their payloads are fairly low, so you're not going to put them in the same space as the traditional 200-kilo robot. So we're dealing with the 4 kilo, maybe to the 30 kilo today. But the compelling story behind collaborative robots is they continue to further reduce the cost of the infrastructure required to deploy these systems. For example, a collaborative robot that can manage its forces and can work side by side with people, all of a sudden you don't need the fencing, you don't need the gate boxes, you don't need all these safety measures that you typically put around and shroud around these robots. So in lieu of the traditional systems of designing people out of an automated system, now you're actually deploying these collaborative robots in a human-centric model. So the collaboration then between humans and robots is becoming very possible. Now, why do we want to do that? Fundamentally, if you go back and look at a person's task in an assembly line, most of us will figure out very quickly that 30 to 70% of that person's time in the assembly process is non-value added. You're going to turn around, you're going to grab a part, you're going to grab a tool, you're doing all these preparatory tasks. Those are called non-value added. And the only value added time is when you insert something into the product. And so the value proposition of collaborative robotics is the fact that now I can have robots intermixed with people and taking some of these non-value added time of part grabbing and giving to the people. So it allows us now to elevate the role of the human in the process to adding value to the product. That's really the new value proposition. The other value to the collaborative robots and why they're so critical in the next 5 to 10 years, it's because they've really shrunk and almost eliminated the upfront cost of engineering. If you think of a traditional robot, you have to design the process, you have to simulate the robot program, you have to develop the code and download that program to the robot. Then you have to have people on the line, and mind you, those are not operators, those are technicians, specialists to modify these programs to make sure they work. Well, today you look at a new robot by Rethink, the Sawyer, where an operator on the line with very little teachings can really teach that robot within 10 minutes, which means now I've collapsed that entire engineering chain of cost up front that's required. And that to me is just the tip of the iceberg. The other biggest feature that you'll see with these robots is the ability to redeploy them very fast. So I can move the robot from one station to the next and redeploy that very quickly. You can't do that today with a traditional robot. So that's really what I believe is the new paradigm and the new space in robotics that you're going to see continue to explode in the next 5 to 10 years.
So collaborative, collapsing the chain is sort of the revolution that's happening now. Extend that out for us to 20 years. What is the what is the role of robotics? What are they going to be capable of doing?
So if you look at robotics today, we've been able to achieve a lot of processes with them, whether material handling, joining, welding, but the one area in my mind that remains unsolved by robotics is assembly. Okay? If you go in the automotive industry today, even with 600-700 robots per factory, you will see 700 employees on the assembly line with 0 robots. And that's because now you're getting into the human factor of dexterity, the perception, the decision making of assembling very complex parts into the product. And some of these parts, as you know, they're compliant. They're not all solid, right? They have foam or wire harnesses and hoses. And so I think the next frontier, I still believe, in robotics is going to be in starting to automate some of these assembly processes. And that's going to be the next frontier in the next 20 years. Between now and then, I will foresee that there will continue to be an escalation of sensors capabilities, gripping capabilities, and mobility capabilities. So mobility is becoming an important play. We've seen robots now in AGVs that can go around and tend multiple machines. But I think the ultimate promise is really when robots are dexterous and can really sense an environment to do the assembly work. That to me is the next frontier. And ultimately, my ultimate vision has been is, and I've said that many times before, is that when engineers join a company today, they get a computer, a laptop, right? Because that's their engineering tool. But I do foresee a future where, for a worker on the line, their tool of the trade that you give them when they join is in fact a collaborative robot that would allow them to maximize their efficiency in that process. That is going to be the ultimate vision, where truly people collaborate with robots, right? It's as an assistive tool to get the job done. But that's really the ultimate vision, is the assembly process. How do we put automation robots into that process that's to date still impermeable by robots?
It sounds like from what you're saying, some of that would include improving cognition, speeding up or making more natural their learning. are those, and I guess what are the big hurdles to getting to that point that where you've got these collaborative robots that are able to pull their own weight with very limited resources?
You know, if you think of robotics, it's truly an interdisciplinary field, but to date you'll see the robotic manipulator arms, that's all they do. You'll see vision companies, that's all they do. You'll see gripper companies, that's all they do. And so what we have not seen is truly an integrated play that can start to combine these things in a system level solution that really adds value. But the challenges remain for vision. To date, with all the advances in vision that we have done, you still deploy robotic solutions today with very controlled lighting environments. Right? When the sun shines in a camera lens, it'll blind it. So we still have some fundamentals that we have not solved. And I'm sure at the research level we have, but at the commercial level, we still don't have robust solutions. And it's not just the lighting, the textures, the colors, black on black, white on white, under various different conditions, recognitions of what parts are and how to grab them. The ultimate challenge will be, frankly, is if you are able to develop robots like the human hand, and of course that's been done already, the challenge is that the human hand is not a fixture. So when you grab something, even though you don't know exactly where it is in your hand. And the question is, when you start to add value into the process and do the assembly, how do you know where that part is? And mind you, it's now already occluded with the vision system that you have on board. And so we have to really start looking at these smart ways, the software and the intelligence, to allow us to manipulate parts. So today we have grippers. I would say dexterity and the ability to manipulate part, not to grab them, but to manipulate them for assembly. That's going to be the ultimate challenge. But it's going to start with that really more of an integrated play of all these technologies that I talked about, sensing, dexterity, and manipulators. And we still don't see that. They're always independent, fragmented companies out there.
Fascinating stuff. Roland, thank you very much for taking the time to talk to us.
Thank you for having me.